All right. Well, welcome everyone and happy World Water Day. I am super excited to host our week-long student forum and kick off today with our guest speakers. So again, I would love for you all to tell us who's in our webinar today. If you're on YouTube, feel free to use our comment section. Tell us where you're from, your school you're from, your organization. We would love to hear from you all. All right. Well, we're going to get started shortly. So as you all are putting your comments in the chat, I see we have someone from Detroit. Awesome. A few people from Los Angeles. Good morning to you. Connecticut, North Carolina, Florida. Awesome. Welcome. Welcome. Well, we're going to get started today. New Jersey. I see a New Jersey just came in. So we're going to get started today. So my name is Portia Ray. I am the program manager for the Water Challenge here at EarthEcho, and I'm happy to jumpstart our first session today, which we're going to focus on water quality. Before I talk about our session, I would like to introduce EarthEcho International and what we stand for. So EarthEcho International is a nonprofit founded by Philippe and Alexandria Cousteau. They are the grandchildren of Jacques Cousteau, who's an ocean explorer. The cool thing about here at EarthEcho and what we try to push throughout all of our programs is that we believe young people, such as yourselves, the ones who's joined us today, you have the power to make change and you have the power to identify solutions in your community. As you participate in the Water Challenge and in our student forum, you are also joining 2 million people around the world who's already participating in our program. With this program, we've reached 146 countries. And also, you can test your water in your community. So again, throughout this week, we're going to have a session every day starting at 1 p.m. Eastern time. We will also be live on YouTube. But in the meantime, if you are out in your community and you are testing your bodies of water or implementing student projects, feel free to share that on social media and also hashtag monitor water. So some housekeeping rules. So for those who are joining us through Zoom, we encourage you to put your questions in the Q&A section. I know a lot of people use the chat, but if you want us to answer your questions directly, feel free to put it in the Q&A. If you are joining us via YouTube, also feel free to use our comment section. All right. And as we pull up our PowerPoint, I would like to take a moment and say hello to our current co-facilitator who will be joining us in a minute. So Gianna, say hi to everyone.
Hi everyone, my name is Gianna Tomassini and I'm an EarthEcho Water Challenge Ambassador, and I will be presenting to you all today.
Awesome, well, thank you for joining us, Gianna. And also, I would like to thank our sponsor today, Xylem Watermark, for funding this student forum and also providing speakers. So as you all continue to watch our session throughout the week, you all meet some Xylem speakers. So now I'm going to give the floor to Gianna so she can talk a little bit more about who she is, where she's from. And all right, we can go to the next slide.
Hi everyone, as I said before, my name is Gianna Tomassini and I'm an EarthEcho Water Challenge Ambassador here in Puerto Rico, San Juan, Puerto Rico actually. And today I will be presenting to you all about water quality and monitoring, as well as show you the different projects us Water Challenge Ambassadors have been working on. So I have been working with EarthEcho for almost a year. I think it's a year in July. And I've participated in many projects that I will talk about right now. For example, in September last year, I hosted an event for Water Monitoring Day with my partners Valentina and Valeria, which are also in my school, and we taught the 5th and 7th grades about water quality. In January, I participated in a mangrove restoration activities with my fellow PR ambassadors, and I will talk about that more after the presentation. And I also hosted an Instagram Live with the Youth Climate Action Coalition in Latin America, which is also a great organization that promotes helping the environment. And obviously, throughout all of these months, I have done my monthly water monitoring tests. Oh, I think the presentation shut down.
It did. Well, thank you, Gianna, for introducing yourself. I will also like to give the floor for Philippe to say hello to everyone. Hi, Philippe. Thanks for joining us.
Hello, everybody. I am so delighted to be here for kicking off this World Water Week and our Student Forum series. So thank you all for joining us, be it on Facebook or YouTube, wherever you're joining us from. It's a terribly important day. I just got off another Zoom with folks through one of our partners, and giving a presentation to folks throughout Europe, the Middle East, and Asia. And we were just talking a lot about water and how the global system is connected, and how important it is to recognize that oftentimes we continue to be in a situation where we undervalue water and the ocean because it's part of one single system. That a lot of people don't really appreciate where their water comes from, which is the core nucleus of the EarthEcho Water Challenge, is helping everybody connect to water in their communities, in their watersheds where they come from. And so this week I'm really delighted, and today, to be able to be a co-facilitator with Gianna, one of our Water Challenge ambassadors, who has done such extraordinary work in Puerto Rico in her communities, and is already such a leader. So, this week is all about kind of kicking it off, and today in particular, but I remind you, I know Portia did as well earlier, but I want to remind everybody that this is the first day. We're doing stuff every single day this week, and it's going to culminate in Friday, which is like the big day where we're not just talking about learning about water and the issues around water. We're going to be talking about all the different types of things we can do to improve the quality of that water. So it's 1 p.m. Eastern time every day this week. Do not miss. We've got amazing speakers. We have, amazing events planned. But today is really about kicking it off. And I just remind everybody again, this is key. Use the Q&A function for asking any questions that you have, please. And we'll get to that at the end. But you heard a little bit from Gianna, and I want to continue to pass it on to her. I'm just thrilled to be here. EarthEcho, we've been at this 15 years. There's a lot of bad news in the world that exists. There's no question about that. Water, ocean, climate, all of these different things, and they're all related. But it's the work that I do with EarthEcho. It's the work every day that my amazing team and I have the privilege to do with young people like you that gives us hope. And I mean that. I truly believe in the optimism and the opportunity that exists for the future because of you all, because we have a new generation that recognizes we're all in this together, and we're not the leaders, or you're not the leaders of tomorrow, you're the leaders of today, and that's very, very important. So anyway, speaking of leaders, I will stop talking. I'm going to be with you the rest of the day here, the rest of this this panel, but I want to pass it on to Gianna because she has such an amazing story to tell. It's inspiring. We talked last week, and we've talked before. Obviously, she's a Water Challenge ambassador, but every time I hear her story, I'm inspired by the work that she does and why she does it, and that's really, really important. So she's going to walk us through that, walk us through why the EarthEcho Water Challenge matters, the types of things that it tests for, which are really fundamental to the health of water systems, which is fundamental to the health of humans and our planet. So anyway, without further ado, I'll pass it back to Gianna.
Thank you all. Now we're gonna dive into water quality, and today we will be joining global efforts as a part of the EarthEcho Water Challenge to explore and protect local waterways. We'll learn more about water quality as well as how people participating in the Water Challenge take water monitoring tests. So I would like to start with this question. What is your connection to water? As we all know, water is an important resource that we all need to survive. So just write your answers in the chat or in the Q&A section, and I'll read them out after I explain what my connection to water is. Many of your answers might differ, and that's totally okay because most of us think of the scientific connection to water first, while others have a more personal connection to water, but that's totally up to you. I know that personally, I connect to water because I have always lived close to the beach and loved going to the beach. And a few years ago, I started noticing how polluted the beaches were getting and how much trash there was on the coastline. And this personally made me connect with the water challenge, since I have always loved going there. And it's really hard to think about the fact that one day there could be no unpolluted beaches. And also, being conscious about the environment has always been a big part of me, since my mom has an eco-friendly printing factory and my aunt has a sustainable farm. And it just really connects with me why we have to be conscious about the environment. So I'm gonna go check in the chat with your answers. Let's see. Oh, here we are. So making memories with my family, that's a good one. Oh, the chat closed. Okay, here we are. Pollution, you love the beach, same. The wildlife and the overall environment, definitely. And we all live on an island. We swim, we paddleboard. That's great. I also live on an island in Puerto Rico. And actually, I forgot to mention, all these pictures in the back, I took them throughout the island of Puerto Rico, except one of them, I think, is in the Dominican Republic, but the rest are all here in Puerto Rico. And this one, I think, is in the one with like the really blue water. I think that's Playa Caracoles. The one under it with a lot of fish, that's like Old San Juan, etc. So yeah.
Well, and Gianna, I just wanted to jump in here. I think what I'm seeing here as a trend for all of these comments is that things like connecting. Here we have from Carolyn, connecting with friends and family. That's the theme here, right? And that's one of the core pieces of the EarthEcho Water Challenge, is remembering or playing basketball at the beach, adventure and discovery. I'm seeing all these great things coming up here. Is that it's not just about water quality for water quality's sake, while that is important. It's about what it is in our communities and what it means to us as people spending time together, being healthy with their families. And that's what it's all about. Water does not come out of our tap. It comes from our community, comes from our rivers, from our lakes, from our groundwater. It comes from our watersheds. It comes from the places around us. And when those places are polluted and suffer, we suffer. And all the things we love to do around playing spike ball and tackle football at the beach, swimming, all of those different things are impacted. So I love, that's a great question. I love what everybody's saying here, because it reminds us that this is a very personal issue for all of us.
Yeah, definitely. And it's really hard to think about that maybe future generations won't have the same experience we do. And it's definitely a terrible thought. But if we act now, maybe in the future, they'll be able to have the same experiences we have with water and how water changes our lives. So where does fresh water come from? Okay, so now I have another question for you guys. What percentage of the surface is covered with water? Or what percentage of the Earth's surface is covered with water? This is a tricky one because I didn't remember this the first time, but then, okay, a lot of you are really close. I saw a few 70s, 75, 73. It's 70, the answer is 70, but good job to all of you. You all were pretty close. Most of the people that wrote were around the 70s, but now let's think of it this way. What percentage of the Earth's resources Earth's water resources are available for human use? you guys can also answer this in the chat. Okay, so most of you wrote 3%. The answer is less than 1%. And actually, although water covers about 70% of the Earth's surface, most of it's in the world's oceans, approximately 97% of that 70%. And it's in the form of salt water, which we cannot use because, of course, it's salt water. And the ocean's remaining 2% is frozen in ice caps and glaciers. Although this is fresh water, it is unavailable to us because it's obviously frozen in these ice caps, and the remaining water, which is the one we use daily, is less than 1%, which is crazy to think about. So now I'm gonna talk about the water cycle. This limited supply of fresh water that we were talking about continuously moves around the Earth and throughout the atmosphere through a process called the water cycle, which I think most of you know about or have heard about in elementary school and all that. So I wanted to discuss it here again to freshen up your memories and also explain what it has to do with our connection to water, as Philippe said earlier. The easiest way to view this cycle is as a circle. Most of you probably know like the circle of life, but the cycle is never ending that we know of. Actually, many of you don't know that the water you're drinking now is the same water that has existed for millions of years. So basically, it is also important to know that the water we collect for our basic everyday needs, such as showering, cleaning, and other purposes, does not come out of the tap, but from our local water resources. So Philippe explained earlier that the water doesn't necessarily just come from the tap, that we're all connected to water. And that is totally true, since we all use water from our local water bodies. And that's why it's important that we protect these local water bodies and of course, keep the water cycle going.
You know, Gianna, one of the things I love to think about in the context of that statistic, that there's no more water today than there ever was, ever will be, and fresh water is this continuous cycle that takes millennia to pass through the whole system. So in essence, we're drinking the same water that dinosaurs drank. I have a cup of tea here. This is dinosaur tea, is what I'm going to call it for the purposes of this conversation. It kind of blows your mind. The planet's been around for billions of years. Life has been evolving for millions and millions of years. And here we have a comment from Charlie. There's no such thing as old water. It is all flowing around, and we're drinking the same water. Imagine that maybe the water you had this morning with some of the same water molecules that a Tyrannosaurus Rex was sipping a few million years ago. So I always think that's really cool when we think about it, and it helps put it into context of just how precious and finite, limited it really is.
Definitely. And it's crazy to think about that dinosaurs use the same water as us and any other animals, honestly, throughout the history of the world, and how everyone has used the water that we're all using. So think of your favorite person from history or people you've studied from history class. They've all used the same water as you. So it's crazy to think about. So there are many issues that affect our water resources, but now I have another question for you guys. What are some examples that you can give me about these issues that affect these resources? Because we talked about pollution earlier, but of course there's other issues that are affecting our water resources. So definitely important to see. Oil spills, that's a huge one. I guess that also can be counted as pollution, but it's a different type of pollution, obviously. water runoff, plastic, pesticides. Yeah, I think the one with the grass and the spray things, that's pesticide, I think. So yeah, fishing is really actually terrible for the environment, climate change, overfishing. So yeah, I saw most of you writing really great ones. Um, but with the limited supply of fresh water on our planet, it's critically important to protect our water resources so that all life on this planet can have water to live, because it's really important for everyone. So issues such as water pollution, mismanagement of stormwater, land use, and the effects of climate change are just a few factors that can affect people's access to water.
Yeah,
And
I just wanted to point that out, to really stress that as we look at things like climate change, start thinking about the impacts of that. The places that had less water will likely have even less water. Places that had too much water may even have even more water. So it's water. The water crisis and the water issue becomes even more timely now with the changes that we're seeing with climate change. And I wanted to make a note about a question that someone asked earlier on the chat, because it's related to this. Is it, don't we lose water when it rains and it lands on the land? That's a really good question. It's a really good thought. But because it reminds us that no, we don't. Because what ends up happening is that water may percolate down into aquifers and be stored there for thousands of years, but eventually it will be part of a system that flows back into the ocean or is brought uptake by plants. And then those plants, the transpiration, as you can see here, the moisture comes out of the plants and into the atmosphere. So no matter what happens, where that water lands, it's all part of a system. And yet when water lands on land, it ends up picking up a lot of the kinds of pollutants that we were just talking about, right? And so that's how you can have pollutants that end up, you can track pollution way up in the middle of the United States, for example, in farms, in farm country, way up the Mississippi River, and it ends up in the ocean. It ends up leaching into groundwater supplies that slowly leach into rivers and streams that end up in the Mississippi, that ends up in the Gulf of Mexico. And so it's all part of the system. Never think that water is ever lost. It is all part of a system, and whatever we end up putting into it, whatever it ends up carrying around, ends up being one of those things that continues to flow through into the system. So yes, water is no matter where it lands on Earth, it's part of a system, the entire water system, and as it passes through, it carries whatever pollutants we put in its way with it.
yeah, I also remember an example that someone told me about that. Whenever you wash your dishes or any utensils that you ever use, that runoff can actually cause algal blooms, which just means that there's a lot more algae in the ocean. So just imagine that every time you wash the dishes, that goes into the ocean or into a lake or into rivers, and it's all connected, because even though you use the water in the tap, where does that water in the tap go? That exactly goes to lakes, to oceans, to aquifers, to all of these places, and eventually gets evaporated or just keeps going in the cycle. So now we're going to see the test, share, protect thing we have here with EarthEcho. Throughout your participation in the EarthEcho Water Challenge, you will join 1.6 million volunteers who have taken action to monitor water quality in 146 countries. I think Portia said this before. And when joining, you'll have the opportunity to test the quality of local surface water from your region, share your data through the EarthEcho Water Challenge global database, which is called monitorwater.org, and discuss strategies to take action to protect your local waterways. So I'm someone that is part of the EarthEcho Water Challenge. I'm an EarthEcho Water Challenge ambassador. So I monitor water every single month. I have to do it, and I sometimes even do it more than once a month. and we're gonna have a little activity with water monitoring later on. So the EarthEcho Water Challenge test kits are for 4 water quality parameters, which are temperature, turbidity, pH, and dissolved oxygen, which is, we just test all this in the water. So here you can see the turbidity stickers, the little tablets we use for the pH and the dissolved oxygen, and also the temperature strips that are right next to the little graph we use to compare everything we get from the tests. So we're gonna explain that now. Okay, so temperature. Testing temperature tells us how hot or cold the water is, and we measure the temperature in degrees Celsius, which is the widely accepted degree for measuring temperature. However, us here in the United States use the Fahrenheit. The first physical test we will talk about is the temperature, and this measurement in the picture, you can see that we will be using this to test water. On this strip, wait, the presentation moved. Okay, there. On this strip, you can see all the numbers in Celsius. Maybe if you are used to Fahrenheit, you won't understand what the numbers mean. But there's the green number right there, which is 32. That is the value of the temperature in that water. So you get the temperature by putting the jar of water in the water for a few minutes, and the one that gets green is the one that is the water, the temperature of the water. However, there is another strip that you can put on the jar, but that one is for colder temperatures, and I personally don't use that one because I live in a tropical island where the coldest it'll get is like 70 degrees. So I have another question for you guys. Why do you think temperature is important, or a specific temperature in the water is important? So, yeah, okay. So I'm gonna let you guys go with the keep answering in the chat while we go to the next slide. So what are some facts about temperature? To determine whether or not temperature is good in a specific place, you must learn about the aquatic organisms that are native to your region. So I saw some people that wrote that the oxygen level is important. That is definitely important, and that it can affect the lives of animals, which is also a big thing. So the lower amount of oxygen affects the rate of photosynthesis, which is the process in which plants make food. And so since temperature can affect the amount of oxygen the water can hold, cold water holds more oxygen than warm water. So now with climate change, if the water gets warmer, then many animals are in risk of dying, or just organisms in general, because they're not used to these hotter temperatures. So all aquatic organisms like fish, insects, plants, they need a certain temperature range to survive and thrive. So if the temperature of a water body rises or falls significantly for a long time, these organisms could become stressed and eventually die. So why do you guys think temperature changes? Obviously, we talked about the different situations that are affecting our local water bodies, and here are 3 of them that are really important. First, the warm water released from factories is a great causation of warmer water, the removal of trees and plants, and the runoff from city streets. So now we're going to talk about turbidity. This is the second physical test we're going to talk about, and this measurement tells us how clear or foggy the water is. So if you hear that the water is very turbid, that means that the water is really foggy. In the picture, you can see the equipment that we'll be using to test the turbidity in the water. The black and white circle you see in the testing jar is called a Secchi disc. By comparing how well you can see the Secchi disc through the sample of water next to a turbidity chart that is right next to the jar with the water, you can see the person holding it. That's how you calculate how turbid the water is. And I have another question for you guys. What do you think makes water turbid? It's a lot of reasons, but you guys answer what you guys know. So I saw pollution, chemicals, algae. We're gonna see in a second in the next slide. But all of these are great answers. So what are some facts about turbidity? In general, the clearer or less turbid the water, the better. If the water tests high for turbidity, that implies that there are solid particles suspended in the water that are making it hazy. So these particles can be bad for water quality because they could clog fish gills and make it hard for them to breathe, and also block light from aquatic plants, which makes it harder for them to go through photosynthesis. Turbid water might also be a result of soil erosion, urban runoff, algae, and the stirring up of bottom sediment. So you guys said a lot of these in the chat, and yeah, they're all true. Turbidity is not the same thing as color, however, because there's many darkly colored waters that aren't necessarily turbid, but they're just darker because the water's deeper or just because they're in a more darker place. So now we're gonna test pH. So to truly, the third physical test we're gonna talk about is this pH, and the measurement tells us how acidic or alkaline the water is. For example, something acidic is like a lemon, and something very alkaline is soap. Some other people, however, say how acidic and basic something is, but alkaline is also another word you can use. In the picture, you can see the equipment that we'll be using. Here is the chart we use to compare the dissolved oxygen, pH, and turbidity. And the vial you can see there, that it's made of plastic, but we call it a vial. And that one, I think, looks like an 8 if you compare it to the chart. But also the person has the tablets we use. So we have a sample of water in the little vial, and we put the tablets, and it gets into that color. It depends what color, obviously, because all the water samples are different, but yeah, you just get a different color each time. So what are some facts about pH? To truly determine whether a reading is acceptable, you should look up the native species of the region. So some species of animals live in more alkaline waters, and some others live in more acidic waters. In general, the majority of freshwater organisms live in a pH range of 5.5 to 8 on a 14-point scale, 0 being the most acidic and 14 being the most alkaline. So most people say that ideally 7 is the best the water can be in, or the best pH the water can be in, because many animals thrive in that environment. So 7 is like the light green one on the chart. Many aquatic animals will stop reproducing at pH levels around 4, and even if levels drop to around 3, adult fish will die. So pH can be affected by things like acid rain, wastewater discharges, drainage from mines, and just different types of rock that can be found in the sea. I'm gonna take a little break just to read some questions in the Q&A section. Okay, first one. Does rust get evaporated with the water when it's in the water, or does it just stay on the ground, and does it pollute if it does? Well, I think when many things are in water, sometimes they do get evaporated, such as that's why things such as acid rain exist when many people just many things get evaporated with the water and fall down as rain again. But there's some things that remain on the ground also. So I wouldn't be able to tell you for sure if rust would get evaporated, but I'm sure that it probably has happened before.
Well, rust is mostly iron, right? Rust is iron. So it can, in theory, evaporate, but the temperatures at which it evaporates are like extremely high. So in typical situation, heavy metals, metals like iron will stay behind. They won't evaporate. No. That's a good question. See a couple other ones here. I've been trying to answer a few of these as we go along. But let's see what else, Gianna. What else do you think?
Well, okay. The next one says, there are many animals in the ocean, so if a certain animal needs warm water and the other needs cold, do the animals that needs the opposite temperature get saved, or they let them die? So I think that naturally the animals that live in cold waters search for cold waters, and then the ones that live in warmer waters search for warmer waters, because obviously there's the different migrations of animals that need colder or warmer waters during the winter or during the summer. Last winter, actually, I saw videos of whales here in the ocean in Puerto Rico. Even though it's colder for us because it's obviously winter, it's a lot warmer for them because they're obviously in a lot colder temperatures. So they look for warmer water since the winter makes the water colder. So I feel like each animal looks for their own environment and lives in that environment.
And that's absolutely right, John. And that's one of the problems with climate change. So I'll give you two quick examples. Puffins. Puffins are those small little birds up tend to be in northern latitudes near the Arctic Circle, and those really colorful beaks, kind of the big. Google it. If you don't know what puffin is, Google them. They're adorable. And fun fact: baby puffins are called pufflets, which is always, or pufflings. Excuse me, pufflings is the name for a baby puffin, which is always, I thought, cute. So puffins feed predominantly on a small surface, long silvery fish, little small fish. And but those fish require a certain, prefer a certain temperature of water. And as warm water is encroaching north into the Arctic because of climate change and the warming ocean, those fish are moving north as well. And so the puffins are having to fly further and further and further to find those fish to feed their babies. And because now these fish are moving so far away from land, the puffins are in many areas are dying out because it's too far. There you go. It's too far for them to be able to get the fish and make it back to land in one go, and to be able to feed their pufflings. So that's one example. In addition, in places like, for example, in New England, in Maine, what you're seeing is lobster are starting to move north because they also want cold water. Unfortunately for the fisher people in Maine, that means that the lobster are moving up into Canada where they can't follow. So it's having a huge economic impact on the lobster fishery in New England. That's just two examples of how animals will pursue the right temperature for their comfort.
Yeah, I also this also affects just animals in general. They don't have to be fish or I saw a documentary, I think, about seals that have to move to different places, and that since the different temperatures, there's like the place that they have to go to, it's smaller because of erosion, and also they have to move farther away because of the warmer temperatures. So they're all crowded, and that some of them, to be out of the crowd, go up like mountains, and then they fall and die because they don't know how to get down. So it's definitely affecting not only fish and crustaceans and all that, but also mammals that need to go to different places for the winter or the summer or just the different season.
Well, and also, you know, when this related to this question, this other question here, what about animals who like hot water? Here's the thing: is that two things. Mostly, the ocean is warming, so animals that prefer warm water are, in some cases, actually, it's getting too warm for them. So coral reefs, for example, that happen in the tropics, or that occur in the tropics, the water is actually getting too hot for them, and so there are not really, it's not really an issue of animals wanting more hot water and searching for it right now. It's an issue of the water being too warm in general. And we're seeing that with people as well. People have a heat tolerance, a certain level of heat that they can tolerate before things get bad. And unfortunately, in the ocean, I know places like the Arctic and Antarctic are very cold for us, but the colder water regions tend to be the most productive and healthy, or not necessarily healthy, but most productive from a life perspective. So in the Antarctic, you have these massive krill populations that grow and bloom, and incredible diversity of life in cold water, an abundance of life and biomass, like enormous biomass in cold water. So it's too cold for us, but ocean animals really like colder water, tend to like colder water. And so as the ocean's warm, it's a big problem for them. And then two quick questions I can answer very quickly here. If we take a filter and takes ocean water, will it still be salty? Depends on the filter. You'll need a more advanced, typically like a reverse osmosis, something like that, that is specially designed to take the salt out of water in order to be able to drink filtered salt water. It's expensive and difficult. Can water evaporate in colder temperatures? Yes, it can. I was up in the Arctic filming with CNN several years ago, and it was minus 40 degrees, but the wind, and it's so dry that my skin dried out. And that's one of the ways you can actually get frostbite is that it sucks the moisture out of your skin and makes you more susceptible to that cold and I got a little bit of frostbite on my nose. But if you cover that, it's not just the temperature, it's the dryness that can cause evaporation to happen in cold temperatures.
Okay, I think now we're gonna keep on going with the presentation. We'll both try to answer your questions after or just during if we have time. So we're gonna talk about dissolved oxygen now. And this is the last chemical test we'll be talking about. And we sometimes write DO for short. So this measurement tells us how much oxygen is available in the water. And believe it or not, fish need it to breathe. So dissolved oxygen is basically what it means in the word, the oxygen that is dissolved in the water, and how much the water has affects how much fish live in it. So we're going to talk about that now. So what are some facts about dissolved oxygen? Living organisms require oxygen to survive. So in general, natural waters with constantly high dissolved oxygen levels are likely to provide healthy and stable environments. DO levels fluctuate seasonally and over a 24-hour period. So it depends on the day how high the dissolved oxygen will be. And obviously this happens with all the tests, but this one is the one that it fluctuates a lot. So it varies with temperature, altitude, the time of day, and cold water can even hold more dissolved oxygen than warm water. So Philippe was saying that colder waters actually house more productive live environments for all these organisms. And that is because of many reasons, but also because it has a higher dissolved oxygen percentage. So DO levels tend to be lower in the early morning because aquatic plants have been resting all night and without sunlight for photosynthesis, which is what creates oxygen. Because photosynthesis, while they absorb some chemicals and carbon dioxide, they release oxygen with the plants. So additionally, high levels of bacteria and large amounts of rotting matter can cause DO levels to decrease because bacteria require a lot of oxygen to decompose organic waste. So this is a little water monitoring experience that I wanted to give you guys. So I went monitoring, I think like 2 weeks ago with my friend Denise, and we went to Ocean Park in Condado, which is in San Juan, Puerto Rico, and I took pictures of all the different monitoring I did and of all the different tests, and I wanted you guys to do it with me. So we're gonna start with dissolved oxygen. Here you have the chart, and here you have the little bottle, the vial right next to it. I want you guys to just write in the chat to see what you guys think is the value of the dissolved oxygen. I saw a lot of you guys writing 4. I think if you click the presentation, it'll say what it is. It is 4, so you guys were right. And now we're going to start with temperature. As you guys remember, before I said that the green number was the one that had the correct temperature. So if you guys write that in the chat, what you guys think it is. It's a little hard to see here, but I think you guys can figure it out. So I saw a lot of you guys writing 28, and that is correct. I think there you go, 28 in degrees Celsius. Obviously, it's not 28 degrees Fahrenheit because we live in Puerto Rico and it's very hot here, tropical island. And here we have the turbidity. I didn't have the little chart next to it, so I had to take a picture of just a random one. But you can see how it, you just compare the little Secchi discs to the actual sample. So that sample has sand in it, but don't let the sand confuse you. Just kind of ignore the sand there, but yeah, just compare it to the water. So I see a lot of zeros, and the zeros are correct. And lastly, we're going to do pH. And here we have the pH chart, and in front we have the vial. And yeah, just compare which one it is. This one's a bit harder because I took longer on this one because sometimes the sunlight can make it look different, but I saw a lot of sevens and 8s. Let's see what it is. It's an 8. Actually, in that picture, it looks more like a 7, but when I compared it to all the pictures I had, is definitely an 8. So good job to all of you. Now we're gonna go to the next slide. So before the presentation, I think I talked about the work I did with EarthEcho, and recently in January 31, I believe, we did a mangrove restoration. So me and the ambassadors from Puerto Rico did the restoration in the Condado Lagoon with the San Juan Bay estuary. So here we all met for the first time and learned about the red, black, and white mangroves and their importance in the ecosystem. We planted red mangroves, which are the ones that live closest to the water, And I think in the picture, you can see the proximity we are to the water, because sometimes the mangroves live like a lot of feet away from the water, because each one has different properties which make it live closer or farther away. So first we wrapped the plants with a ribbon on a wooden stake. I think you can see the wooden stake, us holding it in the picture. And after we did that, we used the hammer to bury the stake so they would be there and not float away. The good thing about planting them during this stage of their life is that they can float in the water if they get untied from the stake. And this gives the red mangrove a chance to spread somewhere else different where we planted them. So actually the little plant, because it's not a seed since it like had grown already a bit, the plant has can like float on the water actually, and then after, if it like gets untied from the stake that we buried there, it can actually just float to another coastline. But sometimes they don't and end up just not being able to get to a coast. But if they do, they can spread their roots there and live there. So also, I think we planted the red mangrove specifically because in the Condado Lagoon, there's different other like types of mangrove. And sometimes when a disease that hits the plants happens, if you put a different species than the one that is like most common there, there's a higher chance of survival for these plants. So yeah.
Well, and I just want to jump in here and remind everybody of why this is so important. As Gianna said, mangroves are critical to coastal habitats. But a couple interesting facts about mangroves: 1 square acre of mangrove can absorb about 1 meter of storm surge. So you have a situation where mangroves are very, very important to coastal marine, protecting coastal habitats and people. We've destroyed mangroves around the world for a variety of different reasons: coastal development, farming, whatever it may be. And we've done so at our peril. For example, several years ago, Typhoon Haiyan devastated the South Pacific, or the Coral Triangle region, Indonesia and Philippines. But first it passed over Palau, which has a healthy, thriving mangrove coastal ecosystem, coral reefs, etc. And there were no fatalities from the storm surge that battered Palau. But in some places like the Philippines and Indonesia, where there has been a lot of degradation to the mangroves, destruction of the coral reefs, thousands of people were killed because of the storm surge from that typhoon. So mangroves provide a very important role. They're also nurseries for fisheries. If any of you like to go out fishing on coastal regions in any warm area of the world, mangroves, at some point, many of those fish species will spend part of their life cycle, ideally, in and amongst mangroves, because all those little roots provide safe places for the babies to hide. And then, of course, mangroves also, 1 square acre of mangrove absorbs more carbon than a square acre of rainforest. So mangroves provide an essential function in the carbon cycle on this planet. And by cutting down so many mangroves, it's one of the big ways that we've disrupted that carbon cycle, in addition to deforestation. And obviously, the main factor has been all the carbon emissions that we have pulled out of the ground, where they've been sequestered for millennia in coal and gas and oil, and pumped it into the air. So mangroves are very, very important. And this kind of mangrove restoration is critical to helping not only to restore local ecosystems, but to helping to combat climate change.
Yeah, and it's definitely important to restore these habitats for these animals, since many acres of mangrove also got lost because of the hurricane that we had here. I think it's almost 4 years since that. But in 2017, we had Hurricane Maria, which was a hurricane that really disrupted everything we had going on. We had no school for a while. We didn't have power. We had, but it didn't just affect us. It affected the whole environment. Like trees were stripped bare. The whole rainforest, the Yunque rainforest was devastated, and definitely replanting and restoring these ecosystems is really important, because specifically here, because it was devastated in 2017 because of that hurricane.
Yeah, great example, Gianna. So I know we're running a little bit short on time. So I think we're gonna be respectful. We only got about 5 minutes left. So I want to make sure that we kind of are able to get through the rest of this. And it's my fault. I love to tell stories. I'm too long-winded, so I will pipe down a little bit here and let us plow through.
So we're just going to share the last two factors or pillars about EarthEcho. We have to share and log our data on monitorwater.org. So we just explained how we did the test. Now with all that information, we add the results on the monitorwater.org website. And after conducting the water testing, you can contribute to this global database in which 1.6 million citizen scientists in 146 countries have made a commitment to testing and protecting their local waterways. Protect. So once you've tested your water quality and share your results, it's also important to consider how your data is being used and what type of actions you could do to protect your local waterways and local water resources. So many of us, for example, many of us Water Challenge ambassadors have had many projects and events promoting water quality and protecting water quality. For example, we already explained the mangrove restoration. I also explained that we did an Instagram live with YCAC Latam in February, I think. And also in September, I had an event and taught people just like you guys about water quality. So it's very important to think about how we can teach other people, because it's actually just not that hard to talk about the environment to other people. And you can just start there. You don't have to plan a huge event. You can just talk to other people and spread the word about the crisis that is hitting our local waterways.
So with that, I know we're wrapping things up. We just wanted to mention a couple things today. We also have the EarthEcho Our Echo Biodiversity Challenge. We wanted to mention to you all and remind you all about. That is a way for you all to get involved in solving biodiversity problems in your community. You can go to ourechochallenge.org and enter. It's open to teams with a teacher or an adult mentor. It's due by April 22nd, by Earth Day, to put in your initial ideas for the things you can do in your community. And then the top 10 finalists will be chosen, and we'll have about a month to come up with their plan for what they're going to do, and compete for prize money between $1,000 and $5,000, where the top 3 winners will be chosen later this summer. So we've got that project going as well. And I know that Xylem Watermark has the Global Student Innovation Challenge that is open to high school and college students. There's all sorts of challenges, programs, mentoring, really terrific opportunities for you all through that program as well. It's free. We wanted to mention that to you as well. We encourage you. Obviously, the EarthEcho Water Challenge is involved with that. We wanted to encourage you all to check that out too, because there's so many opportunities for you all to engage. So again, thank you to Xylem Watermark for making this possible. Thank you all for joining us, for your terrific engagement, for your different questions. Get involved with the EarthEcho Water Challenge. #MonitorWater. Don't forget to tag that on social media so we can follow all the wonderful work that you're doing. And again, you can follow EarthEcho in general at all of these places here. So thank you all very much. Happy World Water Day, and together we can change the world. For the ocean, we are grateful. Thank you.
Thank you, guys.